Hello students, in the last class we have studied about continuity of a function. So you know the basic definition. A function y is equal to f of x is said to be continuous if limit as extends to a f of x is equal to f of a. That means left hand limit should be equal to right hand limit, that's equal to f of a. A function is said to be discontinuous if limit as extends to a minus, that is left hand limit, is not equal to limit as extends to a plus f of x, that is left hand limit is not equal to right hand limit. And for the discontinuity of second kind, limit as extends to a f of x is not equal to f of a. All this we have studied it in the last class and we are solving few problems on continuity. We will continue with the problems in continuity now. So it is given, examine the continuity of the function f of x is equal to x minus 5. It is given, examine the continuity of the function and f of x is equal to x minus 5. So we can consider generally, suppose if I take it as y is equal to x minus 5, what happens if you take x as 0, y will be minus 5. If you take y as 0, x will be 5. So if I write the graph of this function, x is equal to 5, it is plus 5 here, and x is equal to minus 5, so and y is equal to minus 5 somewhere here. So when you draw the graph of the function, it will be like this. This is the graph of the function. You can say that it is continuous. Suppose if I take limit as extends to a f of x, limit as extends to a general point x minus 5, that will be a minus 5. Suppose here if f of x is equal to, you have x minus 5, you put x is equal to a, f of a is equal to a minus 5. So what happens now? Limit as extends to a, f of x is equal to f of a. So what is your conclusion? F is continuous at x is equal to a. That's what we get. I think you have understood how to solve this problem. So limit of the function is equal to f of a. So generally when we wrote the graph, it has been very clear that it is a straight line and it will be continuous at all the points. There is no break in the graph of the function. If there is any break, then we can have concluded that it is not continuous. I think you have understood this problem. Very simple and easy to understand. I take up the next problem. Is given f of x is equal to x squared minus 25 divided by x plus 5. X plus 5. So, what is the, by looking at the graph itself, look at the function itself, will be can conclude what is the domain of f. What is the domain of f? For which value of x it does not exist. That's what you need to check. This function is not defined only when denominator becomes 0. So x plus 5 is 0 means x is equal to minus 5. So it exists except r minus 5. Why? If you put x as minus 5, denominator becomes 0. When denominator becomes 0, f of x is not defined. So I write domain of the function is, domain of f is r minus 5. I think you have understood. You have understood how to find out the domain and range in first PUC, relations and functions. So if you put x as minus 5, it is not defined. So we take all real numbers except minus 5. Then you can take what is limit as extends to a f of x. What happens limit as extends to a f of x? Limit as extends to a f of x. It is x squared minus 25 divided by x plus 5. See, limit as extends to a, if you substitute a squared minus 25 divided by a plus 5. How this can be written as a plus 5 into a minus 5 divided by a plus 5. A plus 5 cancels, you will be getting a minus 5 this is what limit as extends to a f of x. At x is equal to a, f of x is equal to x square minus 25 divided by x plus 1. What happens when you take x is equal to a? A square minus 25 divided by a plus 1. So answer is a minus 5. Same method. So limit as extends to a, f of x is equal to f of a. That's equal to a minus 5. What is your conclusion? F of x is said to be continuous at any point except minus 5. That's why we have written domain of f is r minus of minus 5. R minus of minus 5, that means when you put x as minus 5, f of x is not defined. So since limit as extends to a, f of x is equal to f of a, we can conclude that function is said to be continuous. I take up the next problem. F of x is equal to k. F of x is equal to k is given. You know what is f of x is equal to k? K is a constant function. K is a constant function. You need to test the continuity of the constant function. Let us take limit as extends to a, f of x. Limit as extends to a, f of x is k. That's equal to k itself. So f of x is equal to k. F of a is also k because RHS is a constant function. So what you have got is limit as extends to a, f of x is equal to f of a is equal to k. So f is continuous at x is equal to a. I think you have understood. Very simple. Graphically speaking, how it is. This is x-axis, this is y-axis. So k means, suppose if you take it as k, so constant function will be like this. F of x is equal to k, graph is like this. It is a line parallel to x-axis. Parallel to x-axis. You can see that it is continuous at all the points. There is no breaking the graph of the function. Hence, f of x is equal to k is a continuous function. Okay? F of x is equal to k is a constant function. Even if you take x is equal to a, it is k itself. When you put x is equal to a, that's also k itself. So, f is continuous at x is equal to a, and this is the graph of the function. I think you have understood how to solve this problem. Next, I take up f of x is equal to x. F of x is equal to x. What is that x called as? You know, x is called as an identity function. X is called as an identity function. X is called as an identity function. We need to test whether this function is continuous or not. So, to that end, let us take limit as extends to a, f of x. Limit as extends to a, f of x is nothing but x here. If you substitute the value of x, it will be a. Now, at x is equal to a, let us take f of x is equal to x, f of a will be a. So, limit as extends to a, f of x is equal to f of a is equal to a. What is your conclusion? Therefore, f is a continuous function. So, we conclude that identity function is always continuous. How the graph will be? You know, it is very, very simple. It is optional. You need not write graph in the graph for every function. If you write the graph, you will understand it in detail. See, identity function is a line passing through the origin. This is f of x is equal to x. So, we can see that it is continuous at all the points. That means there is no break in the graph of the function. I have already told you, if there is any break in the graph of the function, then the function is said to be discontinuous. I think you have understood. Constant function is continuous and identity function is said to be continuous. When they have asked you to prove that f of x is equal to k, the constant function is continuous, what you have done? You have taken the limit as extends to a f of x and limit as extends to a k, that is nothing but k itself. At x is equal to a, f of x is k means f of a is also k. So limit as extends to a, f of x is equal to f of a is equal to k. So f is said to be continuous at x is equal to k. You know that the graph is nothing but a line parallel to x axis. Similarly, when you are asked to prove f of x is equal to x as the continuous function, you know f of x is equal to x is an identity function. We take limit as extends to a f of x, limit as extends to a x. So when you put x is equal to a, it is a itself. At x is equal to a, f of a will be a. So since limit as extends to a, f of x is equal to f of a is equal to a, f is said to be a continuous function. Graph is a straight line passing through the origin. I think you have understood these two important problems in which we have proved a constant function is continuous and identity function is also continuous. Let's move on to the next question. Verify whether f of x is equal to x power n is continuous at x is equal to n, where n is a positive integer. I have been asked to prove f of x is equal to x power n as a continuous function. I take limit as extends to a, f of x. I have been asked that it is equal to n. Limit as extends to n. What happens now? It is x power n. So how to evaluate limits? Put x is equal to n. We get n power n. Let us take f of x is equal to x power n. F of n will be n power n. So I conclude limit as extends to n, f of x is equal to f of n. Both are equal to n power n. So it's a finite quantity. I conclude f of x is a continuous function. I write it as continuous function. Since limit as extends to n, f of x is equal to f of n, we conclude that it is a continuous function. I think you have understood this. Now, let's move on to another question. It is given f of x is equal to x squared plus 3 if x is not equal to 0, and 1 if x is equal to 0 at x is equal to 0. We will examine the continuity at x is equal to 0. Let us examine the continuity. See here, f of x is defined as x squared plus 3 if x is not equal to 0. F of x is defined to be 1 if x is equal to 0. What do you mean by x not equal to 0? Which implies that x may be greater than 0 or x is less than 0. Okay? It is not equal to 0 means it may be greater than 0 or less than 0. That means to say that left hand limit and right hand limit are same. Right hand limit are same. Okay, let us take limit as extends to 0 f of x. Which function you are going to take now? Limit as extends to 0 means it is not 0. It approaches 0 by taking either negative values, that is left hand limit, or tends to 0 by taking positive values, that is right hand limit. It is x squared plus 3. Now substitute the limit 0 squared plus 3, you get it as 3. So limit as extends to 0, f of x is equal to 3. Now at x is equal to 0, f of x is equal to 1. Put x is equal to 0, f of x is 1 is a constant function. We have got f of 0 as 1. So limit as x tends to 0, f of x is 3. What is your conclusion? Limit as x tends to 0, f of x is not equal to f of 0. They are not equal. Limit of a function is not equal to f of 0. What is your conclusion now? F is not continuous at x is equal to 0. This function is not said to be continuous at x is equal to 0. It is said to be discontinuous at x is equal to 0. That's what we are going to conclude. F of x is equal to x squared plus 3 for x not equal to 0. Understand this step. This is very important. X not equal to 0 means x may be greater than 0 or x may be less than 0. That means to say left hand limit and right hand limit are same. So x tends to 0, we take x squared plus 3, it is 3. But if you take f of x at x is equal to 0, at x is equal to 0, f of x is given as 1. So if we substitute that value, f of 0, we get it as 1. What is your conclusion? Limit as x tends to 0, f of x is not equal to f of 0. I conclude that f of x is not continuous at x is equal to 0. Think you have understood this problem. I move on to the next one. I move on to the next problem now. Find all the points of discontinuity. That's what the question. Find all the points of discontinuity. Please write down the problem. Find all the points of discontinuity of the function 2x plus 3 if x is less than or equal to 2, 2x minus 3 if x is greater than 2. This is what the question is. So, we need to test for, you have to find out all the points of discontinuity. Remember students, before moving on to this problem, I will teach you one important concept. See, let us take a function f of x is equal to a naught plus, a naught x power n plus a1 x power n minus 1 plus a2 x power n minus 2, etc. up to an. We have got this function. This is what the function is. We can call this as an exponent, that is polynomial function. This is clearly a polynomial function. Now, if you let us take at x is equal to some point a. What is the limit? Limit as x tends to a, f of x is equal to limit as x tends to a naught x power n, a1 x power n minus 1, a2 x power n minus 2, etc. up to an. You apply the limits a naught into a power n, a1 into a power n minus 1, a2 into a power n minus 2, etc. up to an. That is what? Limit as x tends to a f of x. Now, f of x is equal to a naught x power n, a1 x power n minus 1, a2 x power n minus 2, etc. up to an. Put x is equal to a naught x a power n, a1 a power n minus 1, a2 a power n minus 2, etc. up to a. Now, we can compare these two. What happens? Limit as x tends to a, f of x is equal to f of a. So, what is your conclusion? F is continuous at x is equal to a. You have taken a general point a. So, what I call this function f of x as? F of x is a polynomial function. Since f of x is a polynomial function, I generally conclude that every polynomial function polynomial function is continuous. So if you take any polynomial function, it is said to be continuous. This is what the important note you should know. So what is the general meaning? Every polynomial function is said to be continuous. We have proved it in general. I have considered the polynomial function. Further, I have proved that limit as extends to a f of x is equal to f of k. Let us consider, we have what is given in this problem. Very, very, very important. It is, please read the problem carefully. Find all the points of discontinuity. That is the question asked. So let us take all the points we need to test. So I write for x greater than 2, f of x is equal to 2x minus 3. See, greater than 2, it is given 2x minus 3. See what happens when it is given 2x minus 3? It is said to be polynomial. You know, 2x minus 3 is a linear polynomial. So I conclude f is continuous. For all values greater than 2, for x greater than 2, it may be 3, 4, 5, 6, 100, 200, anything. You have to take 2x minus 3, it is said to be continuous. For x less than 2, what is f of x? See, for x less than 2, it is given 2x plus 3. See, again 2x plus 3 is a linear polynomial. We have generally proved that every polynomial function is continuous. So, since 2x plus 3 linear polynomial, f is said to be continuous. For x greater than 2, it is continuous. For x less than 2, it is said to be continuous. Now, test. At x is equal to 2, we have found that for all values x greater than 2, it is continuous. For all values of x less than 2, it is continuous. At x is equal to 2, you take limit as extends to 2 minus f of x. Limit as extends to 2 minus means less than 2. Which is the function defined for x less than 2? It is 2x plus 3. Substitute the values. 2 into 2 plus 3. What is x? 7. So, for left hand limit at x is equal to 2 is 7. Let us take right hand limit. Limit as extends to 2 plus f of x. 2 plus. Limit as extends to 2 plus. What is 2 plus? 2 plus is greater than 2. Which is the function defined for greater than 2? It is 2x minus 3. Substitute the limit. 2 into 2 minus 3, it is equal to 1. See, left hand limit is 7, right hand limit is 1. I conclude limit as extends to 2 minus f of x is not equal to limit as extends to 2 plus f of x. Because left hand limit is 7, right hand limit is 1. So they are not equal. What is your conclusion? F is not continuous at x is equal to 2. At x is equal to 2, it is not continuous. So, which are the points of discontinuity? The only point of discontinuity is x is equal to 2. That means, for all values of x greater than 2, it is said to be continuous because it is a linear polynomial. For all values of x less than 2, it is said to be continuous. Left hand limit, that is at less than 2, it is continuous. Greater than 2, it is continuous. At x is equal to 2, if you calculate, we need to calculate the left hand limit. When you took left hand limit, 2 minus means less than 2. Function defined is 2x plus 3. If we substitute the value of x as 2, then we get 7. Limit as extends to 2 plus, slightly more than 2 means right hand limit, for which the function to be taken is 2x minus 3. If we took that, we have got it as 1. So left hand limit is not equal to right hand limit. Hence we conclude that it is not continuous at x is equal to 2 because limit itself does not exist. So discontinuity of first kind and x is equal to 2 is the only point of discontinuity. What is the conclusion you are writing here? You have to write the conclusion that only point of discontinuity is x is equal to 2. That means for all x greater than 2 it is continuous. For all x less than 2 it is said to be continuous. Okay. So in this, while doing this problem, I have given you one important concept theorem, that is every polynomial function is continuous. I have taken a polynomial in general, and in that at x is equal to a, I have tested that limit as extends to a f of x, we have got one value, and similarly f of a we have found. So we have proved that those two are equal. To prove that polynomial function is said to be continuous. So I think you have understood this particular problem, very important. I take up the next one. Find all the points of discontinuity of the function f of x is equal to x plus 1 if x is greater than or equal to 1, x squared plus 1 if x is less than 1. So they have asked you to find out all the points of continuity. So discontinuity. Find all the points of discontinuity of the function. That's what the question is. Let us start. So they have asked you to find all the points of discontinuity. So to that end, what is the first step? I write for x less than 1, f of x is equal to x squared plus 1. X less than 1, it is given x squared plus 1. You know, it is a quadratic polynomial. We have already proved that every polynomial function is continuous. It may be of any degree. So I conclude f is continuous. Why? F of x is x squared plus 1. For x greater than 1, f of x is x plus 1. F is said to be continuous. So for all x less than 1, for all x greater than 1, for all x less than 1, it is x squared plus 1. For all x greater than 1, it is x plus 1. So for less than 1, it is for quadratic polynomial. For greater than 1, it is a linear polynomial. Anything, it is a polynomial. We have proved that every polynomial function is continuous. So for x less than 1, it is continuous. For x greater than 1, it is continuous. We need to test at x is equal to 1. Please understand the steps properly. At x is equal to 1 means you need to find both left hand limit and right hand limit. Let us try to write it. Limit as x tends to 1 minus f of x less than 1. Limit as x tends to 1 minus. 1 minus means less than 1. Which is the function defined for less than 1? It is x squared plus 1. Apply the limits now. 1 squared plus 1, it is 2. Left hand limit is 2. Limit as x tends to 1 plus f of x. 1 plus. So limit as x tends to 1 plus means greater than 1. Plus 1, 1 plus means greater than 1. Which is the function defined for greater than 1? It is x plus 1. Substitute the value 1 plus 1 which is equal to 2. I think you have understood. 1 plus 1 which is equal to 2. Left hand limit is 2. Right hand limit is 2. Let us take. F of x is taken as x plus 1 for x is equal to 1. See here, greater than or equal to 1. So for equal to 1, we have to take x plus 1. It is 1 plus 1 which is equal to 2. So what is the conclusion we can draw from this? Limit as x tends to 1 minus f of x, left hand limit. Limit as x tends to 1 plus f of x, right hand limit. Left hand limit is equal to right hand limit is equal to f of 1. They are equal. So since they are equal, f is continuous at x is equal to 1. See, let us conclude. For x less than 1, quadratic polynomial continuous. For all x greater than 1, it is linear polynomial continuous. At x is equal to 1, it is continuous. See here, for less than 1 it is continuous. For greater than 1 it is continuous. At x is equal to 1 it is continuous. Now, where the point of discontinuity is? Just we have to conclude there is no point of discontinuity. So, I conclude there is no point of discontinuity. I think you have understood this. They have asked you to write the points of discontinuity. But in this problem, we don't have any point of discontinuity because at x is equal to 1 it is continuous. For x less than 1 it is continuous. For x greater than 1 it is said to be continuous. Therefore, there is no point of discontinuity. That's what the conclusion is. I think you have understood this particular problem. I move on to one more problem now. Very simple. Find all the points of discontinuity of x cube minus 3 if x is less than or equal to 2, and x cube plus 1 if x is greater than 2. We need to find out this. Now, let us try to solve this problem. Again, you have to find all the points of discontinuity. See here, for x less than 2, what is f of x? It is x cube minus 3. Less than 2 is x cube minus 3. What is that x cube minus 3? It is a cubic equation. X cube minus 3 is a cubic equation. So, it is a polynomial. So, I conclude f is continuous. For all x less than 2, it is continuous. I write for x greater than 2. Greater than 2 means you have to take f of x is equal to x cube plus 1. See, what is that x cube plus 1? Cubic polynomial. Again, we conclude that f is continuous. That means, for all values of x less than 2, it is continuous. For all values of x greater than 2, it is continuous. What is the next target? We need to find at x is equal to 2. What happens at x is equal to 2? Now, I write limit as x tends to 2 minus f of x is equal to limit as x tends to 2 minus f of x. What is f of x? Less than 2. For less than 2, it is x cube minus 3. Now 2 cube minus 3, 8 minus 3, it's 5. 2 cube, you have to substitute x as 2. So left hand limit is 5. Let us write right hand limit 2 plus f of x. Limit as x tends to 2 plus. 2 plus means greater than 2. For greater than 2, the function defined is x cube plus 1. What is this? 2 cube plus 1, it is 9. 2 cube is 8, 8 plus 1, it is 9. So, I conclude limit as x tends to 2 minus f of x is not equal to limit as x tends to 2 plus f of x. Function, limit of a function does not exist. What is the inference now? So, f of x is not continuous at x is equal to 2. For x less than 2 it is continuous, for x greater than 2 it is continuous, but for x is equal to 2 it is not continuous because left hand limit is not equal to right hand limit. So which is the point of discontinuity then? So point of discontinuity is x is equal to 2. I think you have understood this. I take up one more problem. Find all the points of discontinuity for f of x is equal to x power 10 minus 1 if x is less than or equal to 1, x square if x is greater than 1. We need to find the points of discontinuity. Now, I write it like this. For x less than 1, f of x is x power 10 minus 1. You know, it is a polynomial. I conclude f is continuous. For x greater than 1, what is f of x? It is x squared. So, it is also a quadratic polynomial. F is continuous. For x less than 1, it is continuous. For x greater than 1, it is continuous. Now we need to test at x is equal to 1. Now, I take limit as x tends to 1 minus f of x is equal to limit as x tends to 1 minus. 1 minus means less than 1. Which is the function defined for less than 1? It is x power 10 minus 1. Substitute the limit 1 power 10 minus 1, it's 1 minus 1, 0. Think you have understood. I take limit as x tends to 1 plus f of x. So RHS limit as x tends to 1 plus means greater than 1. Which is the function defined for greater than 1? It is x squared. Substitute the limit 1 squared 1. See, left hand limit is 0, right hand limit is 1. So what is your conclusion? Limit as x tends to 1 minus f of x is not equal to limit as x tends to 1 plus f of x. That is, left hand limit is not equal to right hand limit. When left hand limit is not equal to right hand limit, we conclude that limit of a function does not exist. So I conclude f is not continuous at x is equal to 1. When the function is not continuous at x is equal to 1, that means at x less than 1 it is continuous. Greater than 1 it is continuous. But at x is equal to 1, left hand limit is not equal to right hand limit, hence it is not said to be continuous. What is the question? Find all the points of discontinuity. So that the point of discontinuity is only one, that is at x is equal to 1. At x is equal to 1, the function is said to be discontinuous. So students, in this class we have solved many problems on continuity. Especially you need to know the difference between examine the continuity and discuss the continuity and find all the points of discontinuity. That's very, very important. When they ask you to find all the points of discontinuity at a particular point, you need to find out for all x less than a, for all points x greater than a, and then at x is equal to a. So that's what, so far we have solved 4 or 5 problems of that type. Think you have understood all these problems. Practice these problems. Tomorrow we will solve more problems on continuity. That's all for the day. Thank you.